Now, if you look at this telephone, if you look at the kind of engineers that used to work, it's electronics engineering, electrical, mechanical, communication. But they worked in silos. They didn't talk much to each other. I would do my job, you do your job, you do your job, and the guy will come with a cable, connect it to your house. If it doesn't work, you will have to wait. I think parents would understand the nuances of how these connections used to work in the 1990s. So it's a silo. That's how I studied my engineering. Mechanical means mechanical. And it's got nothing to do with chemical engineering or electronics engineering. If you go to 1990s, you've got this little mobile phone. I'm skipping the cordless. Cordless phone is gone. Let's say we migrate to this mobile phone, which is not a smartphone, but it makes you call and you can keep it in your pocket and go. Now you see, we added this computer science guy in here because now it requires a bit more sophistication. You've got a whole bunch of PCBs that need to talk. And so now, and you see the circles getting closer. Now these engineers cannot be sitting somewhere working in silo. They had to get closer. That means the interdisciplinary nature started in the 1990s. Now, when we got to the basic smartphones, these people had to interact even more. Now you see the circles are overlapping. This is in the 2000s. Now, how many of you think the cell phone manufacturing requires chemistry or chemical engineering? A lot of you would have never guessed. But we got a whole bunch of new streams coming in. Again, these people had to work very closely. You see chemical engineers, mechanical engineers, chemists, physicists, manufacturing engineering, because that became a bit of a bottleneck. So when you transition from 1990s to 2000, in the span of about 10 to 15 years, the entire landscape of how engineers work, how many new domains are needed for something that we never thought would be beyond communication and electronics engineering. Now, if I go to 2010, now you've got this beautiful smartphone. It's got so many applications that we do everything sitting in front of a smartphone. We don't go anywhere. We don't talk to each other anymore. We talk to our smartphones more than we talk to anybody else. Now, what happened with this is now all these guys are all totally collapsed. You don't look at your department and your program in a tunnel mode. You don't look at, I'm an electronics engineer, so I would not know anything about mechanical or electrical or computer science. You must know something of the other things, because all these guys have to work together to make that smartphone very smart. Now, and you look at that little chip, and that's the beauty. That little chip in a forefinger is what is driving all this interdisciplinary nature of this industry. So a smartphone now requires a lot more disciplines, and the reason is there is more functionality, more features, and silo attitude will not work. Now this gave birth to these emerging areas: electronics and computer engineering, computer communication, electrical and computer. So the domains have collapsed. And these are some of the new programs. And I have not listed cybersecurity in it because at the end of the day, if your phone has to be safe and secure, you must need something embedded in the phone, whether it's in terms of software or hardware, to protect your data. You don't want your photos to go out, do you? I don't think so. That security covers the entire thing. So now you look at the complexity. When this becomes complex, your choice of program should not be complex anymore, because the opportunities in a mobile market, I'm just giving you an example, and you can take any product anywhere in any industry, you've got the same feature now. I've got this little semiconductor fabrication. That little chip that you're seeing on the finger is made in buildings with huge equipments. Those buildings would be the size of a simple, very big airport, your airport in Hyderabad or Chennai. These are not airports like in Coimbatore or Trivandrum. These are much, much larger, fully automated. So that's where the data analytics, and all other expertise come in, because to make that one little chip, you need to invest more than 10,000 crores. And that's where the industry is going. This is just one example. If you take an automotive industry, I just took a cartoon. You look at the number of components and the way the cars come out now. Everything is electronic, everything is smart. It'll tell you where you're going. It'll tell you when your tire pressure is not good. I mean, so many features, sensors, communication, all of this is embedded into it. Now, instead of just if you thought car, you would think mechanical engineering. It's not. It's mechanical plus a whole bunch of other domains. If you go look at green technology, future buildings, future roads, the way buildings are connected to your gadget. It requires a complete slew of interdisciplinary functionalities. So jobs aren't a big problem. You shouldn't think that job is there. You should be thinking, how do I migrate from just remember and understand to being able to analyze, evaluate, and create. The creativity is what will get you the best career you can think of. So I think what I have tried to do is kind of walk you through, and this is in general applicable to any university you choose. However, choose the university that will make it happen.